So next problem. So they mention free stream Mach number and pressure, and we are taking supersonic flow over the flat plate. They asked us to find the maximum pressure on the plate. So we know there will be a pressure distribution and which is constant because of the 2D flow, and they are telling this pressure should be maximum, and condition is there should be attached to oblique shock wave, and we have to find the corresponding theta also. Okay, only Mach number pressure is known, so we have to find maximum pressure and corresponding theta to produce the maximum pressure, and condition is attached to shock. What is the procedure here? This is the flat plate, we have the oblique shock, we don't know the theta, Mach number is fixed, and depends upon the condition this pressure will vary. How to vary this pressure? How to get the maximum pressure?
By increasing theta, sir.
Yeah, correct. What will happen if we increase the theta?
Pressure would increase.
Okay. So if the strength of the shock is increases, then the compression rate will increase. Okay. If the strength increases, compression rate will increase, then pressure behind the oblique shock will increase, right? To increase the strength, we have to increase the theta. If theta increases, beta increases, the shock wave angle increases, then shock strength increases, then compression rate increases, then pressure behind the shock wave increases. Okay, if you make this as 90 degree, it will be detached. So the condition is attached to oblique shock wave. Then which theta you will take it?
So for Mach 2.4, the maximum theta we should consider.
Yeah, for Mach number 2.4, we have to find the theta max, because up to that only the shock is attached. So first step is to find the theta max from the theta beta m graph, because we know Mach number 2.4, corresponding theta max you can find it. Once you know theta max, you can find the corresponding beta. The next step,
So we can find Mn1, and from the normal shock table we will get P2 by P1 ratio.
okay. So once you know m, theta, beta, you can find Mn1. Go to normal shock table, you can find the P2 by P1 ratio. You know the P1, from there you can find P2, which is maximum with attached shock condition. That's it. Good. So from the theta beta m graph for Mach number 2.4, they are finding theta max value. It is around 28.7, but from the graph you can take it around 28 degree. Okay, you cannot, sorry, 29 degree. Okay, you cannot exactly take 28.7 and all. 29 you can take it. Then now you know Mach number and theta, you can find the beta. Here also you may be approximately taking 65 degree. So once you know M1 and beta, you can find Mn1. Then go to the normal shock table, you can find the pressure ratio. From there you can find the P2. Okay, so this is the maximum pressure on the plate with attached oblique shock wave condition. Problem. So they mentioned pressure and Mach number for the free stream. Theta also it is given, and we have to find what is the pressure and Mach number on the wedge and pressure measured by this beta tube. Here how to proceed. So this is the wedge model. Over that there is a pitot tube. So we have to find pressure Mach number on the wedge, also the pressure measured by the pitot tube. So this is M1 P1. What is this? How do we know this pressure and Mach number? I have taken free stream M1 P1. This one. Okay, so here what will happen if you place this wedge in the supersonic flow? There will be an oblique shock wave. So pressure and Mach number behind this will be P2 M2. What is this P? How to denote this P? Pressure measured by the pitot. This is M1 P1 I have taken.
The stagnation pressure.
Yeah, how to denote?
P0.
P naught. Then
P0 P dot.
no, this station, whether it is 1 or 2 or any other thing.
2, sir.
1, sir.
1 or 2. Any other answer? 2 answer. Now we are given 1 and 2. Which one I have to take it?
1.
So 1.
Why 1?
So because in oblique shock, pitot pressure is not considered.
In the oblique shock, that is not considered. I said in the pitot, what type of shock you will get it? If you keep the pitot in the supersonic flow,
Normal shock, sir.
okay, it will be like a bow shock and center will be normal. So here I have supersonic Mach number 3.5 and oblique shock wave convert that into the low supersonic, maybe 3 or 2.5 something. So here also supersonic flow. Then this pitot comes, then there will be another bow shock and this portion will be a normal shock, right?
Yes, sir.
Now what is the number you will give it
Okay.
here?
P0 3.
Good.
Sir, P0 2, sir.
No, 3. This is station 1. In between, this is a region 2 and this is region 3 because there is a bow shock in front of the pitot tube. This portion is normal shock. So this is station 3. You know, across every shock, there will be a stagnation pressure loss, right? So P01 will be high, P02 will be further reduced, P03 will be further reduced. Okay, so what this pitot measures, it is the P03, which is not equal to P01 and P02. Is that clear?
Yes, sir.
So here supersonic, and behind this there will be a subsonic flow. Okay, so we know M1, P1. So we have to find P2, M2 and P03. Is it clear? In this problem?
Yes, sir.
Okay. Any doubt? Someone started something. Okay. So always, if they were given only the object, first step you have to draw the shock wave patterns. Okay. So first step, you have to draw the shock wave pattern. So here you know it will be oblique shock. Always in the supersonic flow in front of the pitot, there will be a normal shock. Don't forget. Okay, now tell how to find P2, M2, P03 procedure. Okay, theta is given. So we know M1 and theta. You can find beta. What is the beta value? So there, if you check, it will be around 48. Once you know the beta, you can find the Mn1. Then go to the gas table, you can find P2 by P1 and Mn2. From Mn2, you can find the M2. From this ratio, you can find P2. Now tell me how to find this P03.
So if we have Mn2 value, so we can go to the normal shock table for Mn2 and we can find the Mn3 value and we can have the ratio for P03 by P02 and from Mn1 and Mn2 we can have
See
P02 by
this,
P01.
1 minute. This Mn2, Mn3, this concept is only for oblique shock.
Yes.
Normal shock, we have to take local Mach number, M2, M3. Only across the oblique shock, we have to take normal component. Across the normal shock, if you are taking, it should be local Mach number M2, M3. You should not take normal across the, normal component across the normal shock. Is that clear? Hello?
Yes, sir. Understood, sir.
Yeah.
Yes, sir.
So we know M2. From that you can, whatever the procedure you are telling, then it is correct. From M2 you can find M3. Also you can find P03 by P02. The next step. So we know M2. Using normal shock, you are finding P03 by P02. How to find this P02? Here I have. Tell me.
So can we use the isentropic table for that particular M2 value?
Yeah, you can use isentropic here, here, and here.
So, sir, we can get the P by P naught ratio because we have P2 there.
Okay. Okay, so we know P2 M2, you can get P02. Then substitute here, you can get the P03. Okay, good. Is that clear? I'll explain once again. So M1 P1 is given. You have to find P2 M2, and this is station 3 P03. So from M1 and theta, first you have to find beta, then Mn1. Once you know the Mn1, you can find P2 by P1 and Mn2. From Mn2, you can find M2. Once you know the M2, using normal shock table, you can find M3 and P03 by P02. Okay. So P2, M2, we found it. Now P03 we have to find. For that P02 we need it. So we know M2, P2 using isentropic table. So here you can apply isentropic. You can find P02 by P2. Then find P02, substitute here, you can find P03. This is the procedure. Is it clear?
Yes, sir.
Okay. So first I am finding beta, then Mn1, then using normal shock. I think here I followed different procedure. Okay, from the normal shock, I am finding Mn2, then M2. As here, additionally, I found this ratio also. Okay, once I know the M2, I am going to the normal shock table. So M3 is not necessary, otherwise you can find it. I am finding P03 by P02. And here, first I am finding P01 from the isentropic using M1. Then substitute here, then P02, then substitute here, you can find P03. This takes more steps. Okay, this is not necessary. Instead, as you explained, so directly you can apply the isentropic in the station 2 instead of applying in the station 1. You can find P02 and you can find P03. Instead of finding P01 first, then 2, then 3, directly you can first find this, then second P03. Is it clear? Here they are giving 3 cases. For that we have to find the total pressure loss. Here first case they are taking only the normal shock. Second case multiple shock system. First oblique shock, then followed by the normal shock. The third case 2 oblique shocks, then finally normal shock. Like that they have given. So first we will try that first case. It will be very easy. So everywhere we are going to find the what is it? So pressure loss. For example, here first you have to find P01, then P02, then you have to compare how much P02 it is there, how much it is reduced in the P02. So here you have to find P01, P02, P03 finally. Then you have to compare P01 and P03 and find how much this P03 is reduced. So here you have to find P01, P02, P03, P04. Here you have to compare these two and tell how much this P04 is reduced. So this is the idea, finding the pressure loss. So in the first case, simple normal shock. They mentioned the Mach number, it is 4 and the P1 is 1 atm. So Mach number is 4, P1 is 1 atm. Using eccentric table, you can find the P01. Okay, first step. and Mach number is common everywhere. In all the cases, same Mach number. So P01 will be same. Is that correct? So in the station 1, we are
Yes,
finding
sir.
stagnation. So P01 is constant. Now we found P01 for all the cases. Now go to the case 1 for normal shock table. For Mach number M1, you can find P02 by P01. So from the normal shock table, we can find, once you know M1, you can find M2, P2 by P1, T2 by T1, all the values. But what we need is only the stagnation pressure ratio. From there, we can find P02, which is 21. So P01 is 151, P02 is 21. Then this is the loss, 130.7 atm. Is it clear? It's very simple, like 2 marks. Simply, we are using the gas table and finding the ratio. From that, we are finding P02. So this is the first value of pressure loss across the normal shock. Then go to the second case. So first oblique shock, then followed by normal shock. And the theta value they mention, it is 25.3. So it is 25.3. So you know the procedure. Once you know the Mach number 4 and theta, you have to find beta. Then you have to find Mn1. So once you know the Mn1, you can find the property across oblique shock wave using normal shock table. You can find Mn2 and P02 by P01 ratio. So P01 already we found it. So directly we can find P02. Okay. And from Mn2 you can find M2. Is it clear up to that?
Yes, sir.
Yes.
Yes, sir.
Okay. So once you know the M2, you can go for the second case, normal shock. Again, same normal shock table. M2 is 2.21. You can find this ratio P03 by P02. Other than that, you can find M3, T3 by P2, T3 by T2, etc. and all. But it is not necessary for this problem. So we are taking only the stagnation pressure ratio. So P02 we found it. Substitute here, you can find the P03. So it is 47. Now the loss is 104. So previously it is 130. Now it is 104. So the stagnation pressure loss is reduced because of the multiple shock system. Okay, so from M1 you will find Mn1, then you will find Mn2, then you will find the M2. Using that M2 you will find M3 or other properties. Okay, don't forget. Now third case, so here we have to split this into 3 parts because we have 2 oblique shocks and 1 normal shock. Here they mention angle is 25.3. Here they mention the angle is 20 degree. So here the procedure is again. So this portion is almost we found it last time itself, the last case itself. From M1 we will find the Mn1, then we will find Mn2 using normal shock table. Once you know Mn1, you can find Mn2 and P02 by P01, right? So P01 is known, you can find P02. From Mn2, you can find M2 also. Is that clear? First case?
Yes, sir.
Yes, sir.
Okay, now tell me how to proceed to this second stage. Second stage you tell, second oblique shock wave with a theta 20 degree. Now tell the procedure, how will you proceed? Hello? So in the station 2, we found Mn2, M2 for this shock. Now how to proceed to the second oblique shock? Which are all the known parameters for this second oblique shock? Theta is known. Then
So Mn2 we have. Mn2 we have.
M2 we have.
Find beta.
which is Mn2 or M2, which is known here?
M2, sir.
M2.
M2. This Mn2 is for this shock. Okay. From M1 and this theta and corresponding beta, we are finding this M11 and Mn2, right? So this is over. Yeah, this Mn2 is for this shock. Next, again, similar to this new case, you have to start. Like Mn1, here you have to take M2, you have to find Mn2. So here Mn2 formula is M2 sine beta. For example, if you take this is beta 1, then this is beta 2, this will be beta 2. Okay. So all the cases you have to take it as a separate problem. Mn, Mn1, then this should be M2, Mn2. Okay, don't take this Mn2 here, because this formula Mn1 is M1 sine beta 1. That beta is for this wave. Here from M2 we are finding another one Mn2. That beta is for this wave. Okay. So from M2 and using this beta 2, we are finding new M2. Then again using the normal shock table, we can find Mn3, then M3, then P03 by P02. P02 we just found it. From there you can find P03. Now how to proceed to the third stage?
So find
We
M3
have
and M3.
The M3 we have, sir.
You have M3. Forget Mn for this normal shock. Okay, there is no Mn. Only
So
local
directly we
max.
can go for M4 value.
So we can find normal shock.
Yeah.
M4.
Okay, so if you know M3, we can find M4 and P04 by P03. M4 is not necessary actually. So only this ratio is required. Once you know the P03 substitute, you can find the P04. Then you can compare P04 and the P01. Is that clear?
Yes, sir.
Okay. Only thing is this 2Mn2. You should be clear. Okay, in a hurry, you should not take the same Mn2 here. Then the total problem, all the answers will be wrong. Okay. Okay, so this and this almost same. So up to P02, M2, they are taking from this case 2 itself. Okay, M2, P02, everything they are taking from the case 2 itself. Then using that M2, using the beta value for the second oblique shock wave, they are finding Mn2 again. Once you know the Mn2 for second oblique shock wave, they are finding Mn3, then M3, then P03 by P02, then P03 value, and finally this ratio on P04. So here they are finding the loss, it is 88. Okay, this only important. So here loss is 130, here loss is 104, here loss is 88. Okay, so if you go for the multiple shock system, the loss is reduced. Always start with local Mach number for the oblique shock. Don't forget. Not only oblique shock, whatever the Mach number shock wave, oblique shock or normal shock, always start the case with the local Mach number M1. From that Mn1, Mn2, M2. Then here also start with the local Mach number M2 from Mn2, Mn3, then M3. Then here also local Mach number directly M4. Don't forget. Always it should be the local Mach number M1, M2, M3. So that's it. What's the time now? 45.
145, sir.
Okay. So let's finish this also. It is easy only. Just we have incident shock, then reflected shock. So both are oblique shock wave. So everywhere the Mach number will be supersonic. Here it will be high, here it will be less. So this is a regular reflection. So we know M1, P1, T1. We have to find property in the station 3. Tell the procedure. So we know M1 and theta. Using that you can find the beta. Okay, once you know the beta, you can find Mn1. Okay, you can find the Mn1 here. Once you know the Mn1, you see the normal shock table, you can find Mn2,
pressure ratio.
P2 by P1, T2 by T1. If you want P02 by P01, you can find it. And from the Mn2, you can find M2. Okay, so first oblique shock wave is over. Then how to proceed to the second oblique shock wave? So here also it should be like a two cases. This is the first case.
So we can find Mn2 using
Theta is 18.2, station 1 and 2. Then second case, reflected shock. Here what is the theta? So what is it? Here it is. So here it is theta. What is the angle here?
Theta only.
That's theta only.
Okay, same
theta
right?
only.
Yeah, so it is same. So for this second oblique shock wave also, the theta is same, 18.2 degree. So from M1 you have to find Mn1, then Mn2, M2. Then how to proceed to the second reflected shock?
So,
You found Mn2, M2 for the first oblique shock wave, that is incident shock. Now we are going for the second shock, reflected shock. How to start?
M2 we can take, and we have
Okay.
theta.
Okay. M2 and theta is known. Then again same procedure. Okay. So here we started with the M1, Mn1, Mn2. Finally M2 we found it. Next case also again you should start with the local Mach number M2. You will find different Mn2 for this. From there you can find Mn3, M3 and these ratios. Okay.
Yes, sir.
Okay. So all the multiple shocks, you should separate it as a different cases. This is separate case, this is separate case. Like that you have to differentiate. Then it will be easy. All the cases should be start with the local Mach number, that you don't forget. Clear?
Yes, sir.
Okay.
Yes, sir.
Okay. So from M1 they found Mn1, then Mn2 these ratios. Then from the M2 they are going for reflected shock. Again from the M2 they are proceeding. M2 T2, M2 theta 2 beta they are finding. Then separate Mn2 for this shock. From that we can find Mn3 and other properties. Wave angle I told you how to measure it. For example, this is the flow deflection angle theta. It will be parallel to this wall, and the shock wave angle will be this one, right? Free stream flow and the shock will give you the shock wave angle beta. So here it is same opposite angle, so they mentioned here. Now come to this third shock wave, the second oblique shock wave. So this is the free stream flow and this is the deflected flow. Now this is our flow deflection angle theta and this is our beta 2, for example, if you take it. Is that clear? From the free stream we have to measure the oblique shock wave angle beta 2 and they are asking this reflection angle. How to find this reflection angle?
So beta minus theta, sir.
Okay. So beta 2 minus theta will give you this phi. Okay, not this phi and beta is same, it is different. Okay. So this is wave angle beta, which is measured with respect to the free stream, and they are asking this reflection angle, which will be beta minus theta. This also they asked. 25.8.